Every 100 years, a cosmic nightmare unfolds. A celestial ballet of death and destruction that would chill the hearts of even the most intrepid explorers. Witness the breathtaking final moments of a star as it spirals into annihilation. As it succumbs to the relentless gravity of a lurking supermassive black hole, its fate is sealed. A scorching accretion disk ignites, and material is flung into the void at millions of kilometers per second. Welcome to Century of Doom, the final seconds of a star consumed by a black hole. But what exactly is this grim spectacle, and what does it reveal about the inner workings of these enigmatic celestial giants? This happens because the gravity on one side of the star is much stronger than the other. It also helps scientists better understand the structure and evolution of galaxies. Further investigation revealed that the outburst was caused by a star that had been ripped apart by the galaxy's supermassive black hole. Advances in telescope technology have made it easier to spot these occurrences, which are thought to be fairly common in the Milky Way. While studying them, scientists hope to learn more about the behavior of matter near black holes and gain insights into the evolution of galaxies. This event, named at 2018 COW, turned out to be a tidal disruption event in which a massive star was ripped apart by the galaxy's central black hole. Studying these events helps astronomers better understand the life cycles of stars and the role they play in shaping galaxies. As they approach the black hole, gravity stretches them into long, thin noodles. Astronomers gave this phenomenon a catchy name, spaghettification. This creates a powerful stellar wind that blasts gas and dust into space. What seems like a paradox is explained by the fact that not everything is pulled into the black hole. Most of the star's mass is blown away during the process. They realized that they were witnessing a star being ripped apart by the galaxy's supermassive black hole. They are also analyzing data from other telescopes to create a comprehensive picture of the event. This includes using radio telescopes to image the lobes of material ejected from the star, and using infrared telescopes to study the hot gas in the accretion disk. Overall, the discovery of this tidal disruption event in the M87 galaxy has generated considerable excitement among astronomers. It offers a rare chance to observe a dramatic and violent event in the life cycle of a star, and provides valuable insights into the behavior of matter near a black hole. As they continue to analyze data and monitor the situation, astronomers hope to make new discoveries that will help them better understand the workings of these fascinating objects. Since then, astronomers have been eagerly anticipating another similar event to study. Their wait ended in 2020 when they discovered a bright X-ray source in the M87 galaxy. Through further observations, they confirmed that they were witnessing a star being consumed by the galaxy's central black hole. This event has provided astronomers with an exciting opportunity to study a tidal disruption event up close. These substances form two huge lobes on either side of the galaxy. For example, we can determine their mass, size, and speed. We can also learn more about the behavior of matter under extreme conditions and gain a better understanding of the life cycle of stars. The material ejected from the star doesn't just stay put. It expands outward at speeds of up to 30,000 kilometers per second. Eventually, it reaches a size of several trillion kilometers. This material is now so far away from the black hole that it's no longer affected by its gravity. It's inevitable that these stars will eventually fall into the black hole, but they put up quite a fight. After all, it takes thousands of years for the process to complete. What made this event particularly remarkable was its brightness. At first, the transient was nearly as bright as an entire galaxy before fading from view a few weeks later. This brightness suggested that a large amount of material had been released into the galaxy's atmosphere, possibly due to the explosion of a supernova. Follow-up observations confirmed that the event had originated from a single star, providing valuable insights into the behavior of stars near black holes. With more observations, astronomers aim to better understand these fascinating events and their role in the universe. This discovery provided valuable information about the mass and location of the black hole, and helped scientists better understand the dynamics of tidal disruption events. One way astronomers detect tidal disruption events is by monitoring the brightness of stars in distant galaxies. If it comes too close, the intense gravity will tear it apart. The tidal force of the black hole compresses the star, causing a significant increase in its temperature. This results in an impressive display of light and energy release. Some of the material from the star forms an accretion disk around the black hole. Hot gas in this disk emits X-rays, which can be observed with special cameras on X-ray telescopes. When a star is ripped apart by a black hole, it can temporarily brighten its host galaxy, making it easier to spot. Another method involves looking for unusual X-ray emissions. Tidal disruption events can produce bright X-ray flares that can be detected by telescopes such as Chandra and XMM Newton. By analyzing the properties of these emissions, astronomers can learn more about the nature of the black hole and the surrounding material. This difference in gravity causes the star to stretch and distort until it is as thin as spaghetti. Once the star is within the black hole's event horizon, it is pulled in and destroyed. The process releases an enormous amount of energy in the form of light and heat. One of the most well-documented cases was the discovery of a star named V404, Cygni, in the year 2020. This event was observed by an international team of researchers who were investigating a binary system containing a black hole and a red giant star. Through their observations, they found that the red giant was gradually being destroyed by the black hole's immense gravitational pull. As the star approached the black hole, it was torn apart and heated to extreme temperatures, emitting bright X-rays and gamma rays. This process revealed some interesting details about the black hole, allowing scientists to estimate its mass and study its behavior. This energy can be detected by telescopes on Earth, providing astronomers with a unique opportunity to study these fascinating objects. The star is mercilessly shredded, twisted into cosmic spaghetti, and devoured in a horrifying yet mesmerizing process known as tidal disruption. And as the black hole gorges itself on its prey, it unleashes a spectacular flare of light X-rays and shock waves that reverberate across the cosmos, reaching as far as 10,000 light-years away. This terrifying spectacle is not a scene from a science fiction movie, but a horrifying reality of the unforgiving laws of physics. Using ultra-detailed observations from cutting-edge telescopes, like Hubble and ESO's VLT, scientists have captured this violent ballet where stellar flesh is torn. Join us as we peer into the abyss and uncover the secrets of this century-long horror show. Once every 100 years, a nearby star wanders too close to a supermassive black hole and gets ripped apart in a process known as tidal disruption. These events are extremely rare, occurring only once or twice a year in the Milky Way. However, they are incredibly violent and can release an astonishing amount of energy equivalent to the power of hundreds of billions of suns. That's why when one of these events occurs, astronomers are eager to study it. As the unfortunate star approaches the black hole, it experiences a force known as spaghettification. The study of tidal disruption events provides valuable insights into the behavior of matter near a black hole. One notable example of a tidal disruption event was discovered in 2005, when a team of astronomers, led by astrophysicist David Pooley, noticed an outburst from a bright X-ray source in the center of the galaxy NGC 5506. However, detecting these events can be challenging as they occur relatively far away and are often obscured by dust. In recent years, astronomers have witnessed several remarkable examples of stars being consumed by supermassive black holes. Another intriguing case occurred in 2018 when astronomers discovered a fast blue optical transient in the M82 galaxy. These examples demonstrate the incredible power of supermassive black holes and their ability to influence the stars around them. Some of these stars might be up to 10 times larger than our Sun, but they face the same fate. First, the star begins to orbit the black hole. When the star gets even closer to the black hole, the radiation pressure from the accretion disk starts pushing against the star. It might seem counterintuitive, but when the star is completely destroyed, it actually grows in size. Studying these events gives us valuable information about the properties of supermassive black holes. One such event was observed in 2004 when astronomers noticed an unusual increase in brightness in the center of the galaxy NGC 5506. By observing the characteristics of the X-ray emissions, astronomers hope to gain insights into the nature of the black hole and the surrounding material.